All right, so as Michael said, I've been studying virtual human systems for 2 years full-time. I just finished a master's in virtual human systems. I started my career as a travel writer. My chief claim to fame is writing the first book about travel information on the internet in 1994. When people stopped buying my books, I became seized with the idea of making talking books. And this led me on a journey into dialogue systems and chatbots. So I've worked, 15 years with dialogue systems and chatbots. I spent 2 years in India, in Bangalore, 2013 to 2015, working on chatbot projects. And when I spent all of my savings on unsuccessful chatbot projects in Bangalore, I came back to Australia and was like, what am I going to do? And then it was 2016, and Facebook opened Messenger to automation, to chatbots. And that started this massive tsunami that we have today, this hype cycle surrounding chatbots. So it was actually the Nadia project, which Nick was part of, and Unique started from that point. Unique used to be called FaceMe, but it was an Australian government project. That gave me the idea to go and study virtual human systems. And so that's when I started working on this master's degree, because the tsunami of this chatbot hype cycle had kind of passed me by and left me in the dust. And so then I decided, how am I going to leapfrog ahead to embodiment, to virtual human embodiment? So I reviewed the academic literature, and I identified 3 major researchers in virtual human systems, historical researchers. I identified their research units, and I identified the tools that they were using. So the researchers were Skip Rizzo, Mel Slater, and Jeremy Bailenson. And Skip Rizzo is at the University of Southern California Institute for Creative Technologies. Mel Slater has the Barcelona Event Lab. That's experimental virtual environments for neuroscience and technology. And Jeremy Bailenson has the Stanford Virtual Human Interaction Lab. And the 3 frameworks that they're using that I extracted, and I don't think anybody's compared these frameworks as such, because they use these virtual human systems for research, for other things. So the 3 frameworks were the Virtual Human Toolkit and PIAVCA. PIAVCA is Platform Independent Architecture for Virtual Characters and Avatars. And the third one is WorldViz, Vizard. So the Virtual Human Toolkit is probably the prototypical virtual human system, because it contains a behavior realizer. That behavior realizer is called SmartBody, and it contains a dialogue system, the NPC editor. So this is a diagram of PIAVCA. PIAVCA is the Platform Independent Architecture for Virtual Characters and Avatars, and it also contains behavior realization and dialogue systems. So that was my purpose in looking at all these virtual human systems, was to locate the dialogue system inside it. But what I found was behavior realization, the behavior realizer. And that is, I could write another master's degree, I could write a PhD on behavior realization, because you could have it can be manually done with humans, it can be semi-automated with rules, or it can be fully automated with machine learning, and that hasn't been done very much. There is another presentation here at SIGGRAPH about neural state machines, which should be very interesting. All right, so this is WorldViz Vizard, and WorldViz Vizard is a different animal. So it's a simulation environment with prefabricated virtual humans. And it corresponds to the contemporary virtual human systems. So after I studied the 3 historical virtual human systems, I studied 3 contemporary virtual human systems, and I worked in them. So I worked in Unity, I worked in the new Linden Lab Sansar VR world, and I worked in Amazon Sumerian, which is a virtual actor system. And this is a picture of a virtual human project in Unity game engine. It's called Kala Chakra Tanka. And when it was approached, the painting was approached, that's the Kala Chakra Tanka, then the head of Buddha came out and started talking and describing the painting and what the significance of the painting was. So that was the first project. Second project, this is in Sansar. This is called Digital Human Gathering, and you can visit that today. But this project, I worked with like heterogeneous digital human models and with spatial sound. And it was quite a learning curve, it really was. You can see this today in Sansar, and I recommend it. All right, Sumerian. Sumerian is something like WorldViz Vizard. So Sumerian is an Amazon product, and it's integrated with AWS, Amazon Web Services. So this is also a virtual actor system where it comes with prefabricated hosts, is what they call them. But you can program them to be voice interactive in VR, in web VR. And it's often used for kiosk systems. There's a company in Sydney that's selling finished kiosk systems for about $40,000, made with Amazon Sumerian. So Amazon Sumerian is based on Amazon Lex and Amazon Poly, which are AWS services. And they're integrated at the core in the state machine. And state machines are really very interesting because they're similar to robotic process automation. And we've heard about robotic process automation today. Well, what struck me in these 3 different systems was how similar development of virtual humans was in all 3 of these systems. All right, so from these 6 virtual human systems, I abstracted a model for virtual human structure. And at the core is the behavior realizer and the dialogue system, okay? And that is coordinated in the end with a state machine. But a state machine is a primitive cognitive architecture, but there are not a lot of good examples of cognitive architectures in production today. So this state machine and robotic process automation is, is about as close as we get in the marketplace, actually. So next, what I learned was how conversational AI gets into virtual humans, gets into virtual reality. And the next question I was hit with, how does it get out of virtual reality? How does artificial intelligence, how does conversational artificial intelligence get out of virtual reality? It gets out of virtual reality at the point of consumption, at the consumer, at the end user. And so what I've seen is I learned something that I didn't expect to learn, and it's about the monetization of virtual humans, because until now, virtual humans have been limited to, asynchronous systems or location-dependent systems. But with this migration of processing to the cloud, for instance, cloud rendering, and cloud rendering coupled with 5G is going to allow the mass market distribution of virtual humans very soon, everywhere. So to wrap it up, I will say that my vision for the future is beyond gaming, it's beyond entertainment. My vision for the future of virtual humans is as a humanoid interface for the Internet of Things and what I believe will become ubiquitous 3D. And that's my contribution to the monetization of virtual humans.